Okay, here we go, guys. Lesson 1.2, evaluating expressions. Problem number 1, 4x. It does say evaluate each expression when x equals 6. We know we can do this problem in our head. I know that. Our purpose, our focus right now is to actually understand the format for which we're going to do this. So know that every time you substitute in for a variable, wherever the variable was, in place of it, we need to put a set of parentheses. Just get into that habit now. It's going to help you later, I promise. I'm even going to put a highlight around it today just to make it stand out quite a bit. And it said when x equals 6, so third line of work down, you end up with 24. Number 2, x minus 8. Again, we're going to put the parentheses where we're going to substitute in. Highlight it to make it stand out for today. 6 minus 8. We know that 6 minus 8, if you had $6 and you spent 8, you'd be -2. But we're going to try to practice the integer rules now for 8th grade. So here we are with the integer rule number 3, which says, if a number is followed by a minus sign, change the minus to a plus, find the inverse of the following number, then use rule 1 or 2. Don't forget to look in Handy Dandy. Handy Dandy has all your integer rules. Integer rule number 2 is the one we're going to want to use now. It's for adding, and they're unlike signs. This is positive, this is positive, this one's negative. So 2 unlike signs, subtract the smaller from the larger, ignoring signs, keep the sign of the larger. If I'm ignoring signs, I have a 6 and an 8. The 8 is larger, its sign is negative, so is my answer. Skip a line again. We've got 6x plus 7. Always using order of operations. So we've got 36 plus 7. Out to the side is where you're going to want to do any work. Don't do it in here in your problem. Take it out to the side, any work that you need to do, and then take it back into the problem for your answer. Number 4, 3 times the quantity x minus 5. It's good to get to practice how to read these problems. And on this one, you're going to notice, you're going to want to have the habit of just throwing the number in there. But get into the practice of putting the set of parentheses anyway. Still put those set of parentheses where we're going to substitute in the 6. So 6 minus 5 is 1. Copy the rest of the stinking problem. I know nobody wants to, but we get to. Yay! And 3 is our answer. All right, number 5. It reads, see if you can read it from your worksheet, -5. Instead of saying parentheses, how would I read that? It would be -5 times the quantity, x minus 10 end quantity. So here we have -5, and we're going to put a set of parentheses. Fill in that 6. Order of op says I have to do what's in parentheses first. So 6 minus 10 is -4. Or change the minus to a plus. Find the inverse. Then use rule 1 or 2. 2 unlike signs. Subtract the smaller from the larger. Ignoring signs. Keep the sign of the larger. 10 is bigger. If I ignore all the signs, 10 is larger. And so its sign is negative. Copy the rest of the stinking problem, and a negative and a negative make a positive. All right, number 6. Oh, we worked this one in class earlier. All right. 2 times the quantity, x minus 1, end quantity squared, plus 1. Inside here, we have a set of parentheses where we're going to substitute. We've got 6 inside there. So order of ops says I have to do... Oh, wait, do I have to do order of ops on everything? I mean, it didn't say order of ops. It didn't say to use order of ops. Do you remember when I talked to you about that heart? Like if I ever write a heart or show you a reminder? Always and forever. Order of operations is there now, always and forever. It always has been, it always will be. We just maybe didn't know about it before. So yes, order of ops always and forever. So we'll start with parentheses, cover up what's outside of it so you can focus in there. We've got 6 minus 1, which is 5. Copy the rest of the stinking problem. Now from here, what's going to go on the next line? Give you a second to think about that. Yeah, it'll be 2 times 25 because we did exponents next. The job of the exponent tells you how many of this base to write down and multiply together. Take that 25 back into the problem. Our next line would then be 2 times 25 plus 1. What should be on my 5th line of work? Yep, 50 plus 1, and then finally 51. Nice work so far. Let's keep going. The next section now says, I'm going up to the top, don't forget to fold your paper in half, work down in 2 columns, algebra style. It's the way we like it. Evaluate each expression for the given value. It gives us 2x plus 3, it says, when x equals 4. So we'll go ahead and substitute in. Remember, we're working on functions. Today you made a little function monster in class. That was fun. I saw a lot of creativity. And remember, there's an input. The function means work. You do the work for the equation, and it spits out an answer as your output. So here, we're just doing the input here. We're inputting our 4, substituting it in. Next line of work, and your final line of work. How'd you do? All right, number 8. 12 minus 3d when d equals 2. Don't forget to pause this every once in a while and see what you can do on your own. Work ahead of me. I love it when you work ahead of me so you can see how you're doing on your own. 12 minus, I've got to do my multiplying first before I do any minusing. So I've got to get my 6 here. 12 minus 6 is 6. Number 9. 10 times the quantity, y plus 5. It says when y equals negative 7. So we have negative 7 that's going to go inside that set of parentheses in there. Put negative 7 in there. Inside parentheses, we've got 2 unlike signs. Subtract the smaller from the larger, ignoring signs. Keep the sign of the larger. 7's larger when you're ignoring signs. It's negative. Copy the rest of the stinking problem. And we end up with negative 20. Number 10, 5p minus 1 divided by 2 when p equals 3. Go ahead and plug in the 3, substitute that value in for x. Fraction bar, we have to take care of the top first, then the bottom. Bottom's already taken care of. Let's take care of the top. 5 times 3 is 15. We still have to subtract 1 from that, which would give us 14, still divided by 2. And now 14 divided by 2 is 7. All right, number 10, we're done with that one. Okay, number 11, 6a squared minus 14 when a equals 3. Go ahead and substitute in that 3. Order of operations, we got to go left to right and stop if we see parentheses or any grouping symbols, and stop. I see parentheses, but nothing inside to do, so we're good there. Next, E, exponents, and stop. The job of the exponent tells me if there's 2 of this number written down and multiplied together. That's 9. Copy the rest of the stinking problem. Here we have 9 times 6, which is 54, and then finally subtract, and we end up with 40. Number 12, 7m plus 1 when m equals a half. Do not be afraid of these fractions. Remember today we talked about of means times. Times means of in math. If you were to read this right here, you would tell me 7 times a half. So don't forget, this actually can say of. Right here, we just need half of 7. That's all we're trying to find is half of 7. So take it out to the side if you need to, if you can't picture that in your head. I usually can't. 7 times a half. If you're multiplying fractions, you have to have 2 fractions. How do I make a whole number into a fraction? Yeah, put it over 1. 7 times 1, multiply, just fly right by. You don't have to have a common denominator. So fly by on the bottom, 1 times 2, 2. So that gave me 7 halves plus 1. Well, that didn't really help me out any. This right here is an improper fraction. The way to change it into mixed, you just divide. That's what that divide bar says. 7 divided by 2. The way I remember which one goes inside the bar, I think of this like a diving board. And this is the diver. He's on the diving board. He wants to go inside the pool. He wants to land in the pool, hopefully. I hope he lands in the pool. So 7 goes there, 2 goes there. And I've got to ask myself, right above the 7, what times 2 is close to 7 but not too big? It'd be a 3. 3 times 2 is 6. I get a difference of 1. At this point, it's in fraction form. I don't want to put a decimal 0 and keep going to put it in decimal form. Here's how you do it into fraction form. I call it clockwise because you start at the top of the clock and you go around clockwise to get 3 and 1/2. 3 and 1/2. 7 divided by 2, or half of 7, is 3 1/2. So now if I was actually to put that back into my problem up here, 3 1/2 plus 1, 3 1/2 plus 1 is actually 4 1/2. Okie dokie. That was pretty painless. Number 13. 4 times the quantity 2x plus 1 and quantity minus 5 when x is -2. So let's put the -2 in there. Inside the parentheses, we have to do that first. Once you're in there, you start order of ops over again. So I'm going to cover up anything outside the parentheses. And now left to right, start order of ops again. Parentheses first. I have some, but nothing inside to do. Exponents, don't see any. Next is any multiplying or dividing left to right. And stop. 2 times 2, 4, and negative and positive makes a positive. Nope, I just made that up, didn't I? Negative and positive makes a negative. I do make one mistake a year. There it was. Okay. And now we've got 4. Copy the rest of the stinking problem. Still inside the parentheses. Now we've got 2 unlike signs. Subtract the smaller from the larger, ignoring signs. Keep the sign of the larger. Negative and a positive make a negative. All right, that was number 13. Number 14. We are almost done here, folks. -2y plus 3 times the quantity y minus 1 when y equals -1, it says. Substitute that in. Inside the parentheses, we have, if a number is followed by a minus sign, change the minus to a plus, find the inverse of the following number, then use rule 1 or 2. And now we've got 2 like signs, add and keep the sign. Copy the rest of the stinking problem. We can also substitute in that y right here. We subbed it in here, and it goes in here. They're both y's. Left to right, I'm looking for any parentheses. I have some, nothing inside, no exponents. Any multiplying or stop multiplying. 2 times 1, 2, and a negative makes positive. 6, negative. 2 unlike signs. This is rule number 2. 2 unlike signs, subtract the smaller from the larger, ignoring signs. Keep the sign of the larger. All right. Next section, the last section, 15. State whether each equation is true or false for the given values of the variables. So we've got 2x minus 4y equals 8. It says when x is 4 and when y equals 0. Show me where you're going to substitute in. This is part of the whole 8th grade standard that you know how and where to show that you've substituted. So we're going to put what are we going to put? 4 here, 0 here. Is that how you set it up? And then order of operations. So we've got 8 minus 0 equals 8. Copy the rest of the problem. Over here, 8 take away nothing is 8. And here you're going to put a balance. We've got a balance box here. This is a balance. If this was like a teeter-totter or a scale, it's like if you had 8 pounds on one side and 8 pounds on the other side, it would balance out in the middle. We've got 8 equals 8. This is a true statement. 8 equals 8 is true. So it is true that these work in here to make balance. Number 16. 3y plus 5 equals x. It says when x equals 14, make sure you try to set these up on your own, because sometimes people put these in backwards. See if you can put the correct ones in there. And a good tip whenever you're watching tutorial videos, pause the video often to see if you did it correctly on your own. 14 goes here, 3 goes here, 3 times 3, 9, plus 5. 14 does equal 14. There's your balance box. That is a true statement. T-R-U-E, true. Number 17. Y equals 7 plus 1/4 x. Set that up so that you've got your substituting ready. Substitute in, plug in the correct ones in the correct spot. And now over here, I've got some parentheses, but nothing inside to do. Next would be any multiplying or dividing. I've got some multiplying. If I had 4 quarter pieces, 1/4, 1, 2, 3, 4, that makes a whole. But let's do it step by step to see how we're getting that. 1/4 times 4. If you're multiplying fractions, you got to have 2 fractions. Now they're 2 fractions. Multiply, just fly right by. 1 times 4, 4. Across the bottom, 4 times 1, 4. Running out of paper. 4 divided by, there's my divide bar. Whoop, whoop. 4 divided by 4 is 1. Copy the rest of the stinking problem. 8 equals 8. That is a true statement. Lots of true ones. Hope we get a false one soon. Let's try false. Come on, go false. Number 18. Scroll down. 3 times the quantity x plus 1 equals 6y. Plug in your variables without me. See if you can do it all by yourself. Get them set up correctly. It says what x is -5 and y is -3. Ooh, feels like we're on a boat. Lots of waves. Keep it smooth. Here we go. Inside the parentheses, 2 unlike signs. Subtract the smaller from the larger, ignoring signs. Keep the sign of the larger. Copy the rest of the stinking problem. Here we've got some multiplying to do. It's almost like 2 separate problems. You take care of one side, and you take care of the other side. So on this side, we did our parentheses first, and now we're down to multiplying or dividing. I do see some multiplying. On this side, take care of that. 18 does not, -18 does not, remember that from 7th grade? 6th grade, actually. So -18 does not equal -12. So this is a false statement. Okay, number 19, 1/2 x plus 1/4 y equals 8. 1/2 x plus 1/4 y equals 8. Fill in where you know those go. Whoops, there's my... And we're back. Okay, you got those substituted in now. This side's already solved, so we've got to take care of this side here. Put this over 1. Across the top, 1 times 2 is 2. Across the bottom, 2 times 1 is 2. Plus, let's do the same thing on this one. To multiply these fractions, 1 times 12 is 12. 4 times 1 is 4. Copy the rest of the problem. 2 divided by 2, 1. 3, 8, 4 does not equal 8. This one is false. Boom, and we are done.